next topic is uncertainty measurement. So uncertainty measurement, we have subdivision that is scientific notation, significant figures, and dimension analysis. See, in a chemistry study of chemistry, there are two data. One is the experimental data, another one is the theoretical experimental and the theoretical data. That is the theoretical calculation. So there are the meaningful ways to handle the number of the conveniently and the presence of the data is realistically with the certainties that is the extent possible. Okay. See, the first one is the scientific notation. Scientific notations. Second one is significant figure. Third one is dimension analysis. Dimension analysis. Okay, first we will discuss the significant notation. The significance of notations we are using that the study of atoms and molecules, that is which have the extremely low masses and present in the extremely large numbers. Extremely low masses and large numbers, extremely large numbers. So for example, that's the chemist deals with the large number. For example, 602 20 00 00 00, like this, going like this way. It's a very, the molecules of, there is two molecules of 2 gram of hydrogen, this gas are a small number, like small numbers mean 0.0000, this, these are the very small numbers, like this. So mass of hydrogen atom, that's similarly the other constant is called, that is Planck's constant, the speed of light, charges and the particles, etc. So this is the involves the number of the magnitude. So it's the count number of involving many zeros, but the offers of real changes to simple the mathematical operations of addition, subtraction, multiplication and division, whatever it is. So so you can write any two numbers the above this, you can write the above, try to one of the operation, like accept the challenge, and that will you really appreciate that the difficulty of the handling such numbers. For example, 10 powers. So you can write in the number of that is the in mathematical expression 10, you can write in the 10 powers. Similarly, this number you can write in the 10 powers. That is the scientific notation, like a number, that is the exponential notation in which any number can be represented from the n into 10 power n. So here the n is the number integer and this n is a exponential factor. So this is the exponential factor. The exponential factor may be positive or negative. Okay, that we can write for example 232.508. So it we can write like this 2.32508 into 10 power 2. Okay, so the based on that point, already you were aware of that 10 powers, like this the point decimal value, then this means the decimal had to be moved to the left by 2 places. Here 2 places, this means 232 point will become 2.32, so 2 decimal places. So the same, the exponent is what, power 2, that is the 10 in the scientific notation. Similarly 0.00014, so it can be write 1.4 into what, 10 power, so number of count 1 2 3 So that you have to write 10 power minus 4. So this is the exponent scientific notation. This is the number integers, and this is the exponent notation. So this is the mathematical operation. Then the multiplications and division. Next is multiplication and division. So that two operations that is follow the same rule, which are that exponential number, that is 5.6 into 10 power 5 into 6.9 10 power 8. So you have to write first the 10 power. What are the 10 power? Just add the power values. Here 10 power 5 and the 10 power 8. Just you can take the 10 power value, just 10 as a constant, then just add 5 plus 8. Okay, 5 plus 8. Then just write 5.6 and 6.9. You can write the 5.6 and 6.9. So now it will become, the value is same. So 5 plus 8 is 13. So that it will become this into this. So calculation of this value, you will be getting 38.64 into 10 power 13. So here the 10 power 13, further you can simplify 3.864 10 power 14. The number of the decimal value indicates rise the powers of the 10 powers of the numbers. Okay. Similar way for division, you can also that one more examples are there, that is 9.8 into 10 power minus 2. This is the negative value, and the 2.5 into 10 power minus 6. Now here you have to add again that same rule you have to follow. So 9.8 and 2.5. Here the 10 power minus 2 and 10 power minus 6. So 10 is a common number, then the minus 2 plus minus 6. So it will become minus 8. So 9.8 into 2.5, 10 power minus 2 minus 6, it will become 10 power minus 8. So the final value of 9.8 into 2.5 is 24.50 into 10 power minus 8. So if I write like this 2.450, it will become what? 10 power minus 7. So in positive value you have to add the number, negative value you have to reduce the numbers. Okay. So that you know, I knew that. Then division, this is the multiplication. Suppose if you get the division value 2.7 into 10 power minus 3 divided by, this is the division, so that 5.5 into 10 power 4. See here, now just you have to write like this 2.7, just take a 10 power value and divided into 5.5. You have to divide this value. The 10 power value is, the 10 power value, just put 10 here. This is minus 3. This 4 will become, this is plus 4, and numerator comes in numerator, it will become what? Minus 4. So here also plus to minus 4. So minus 7. So the final value is 2.7 divided by 5.5 into 10 power minus 7. Okay. So this division value is 0.4909 into 10 power minus 7. So if I put the value in right hand side, in left hand side you have to reduce that number. In right hand side, going towards the right hand side, 4.909, it will become 10 power minus 8. Okay. So this is the multiplication and the division. Addition and subtraction we will see. See, addition and subtraction. The first numbers of the written such a way that the similar way that the coefficients are added or subtracted. As the case maybe for adding, like the 6.65 into 10 power minus 4, sorry, 10 power plus 4, and 8.95 10 power 3. So for adding, that exponent is different. See, this exponent is different here, plus 4 and the plus 3. So you have to convert the same exponent. That is the convenient way to calculation. So that you have to convert like this, 8.95. So you have to convert the exponent value so that 0 point, it will become what? 0.895. The exponent is 10 power 4. Now this also 4 and this also 10 power 4. So the changing the exponent value, that means the same number, same for the both value. Now you can add the following number, 6.65 plus 0.895. Now the value is into 10 power 4. Okay, the final value is 7.545 into 10 power 4. Similarly, the subtractions of the two number is, this is for subtraction. 2.5 into 10 power minus 2 minus 4.8 into 10 power minus 3. So look at here, the exponent value for this changes. So you have to convert the exponent value. So what you have to do, the 4.8, the 4.8, first look at the lesser number here. Here look at the higher number, just converting for this. So 4.8 will become 0.48 10 power minus 2. We can write this value 0.48 10 power minus 2. Now we can subtract the two value. So 2.5 minus 0.48 10 power minus 2. So this is the value. The final value will become 2.02 into 10 power minus 2. So this is for addition and subtraction. Next we can discuss the significant figures. This having two types. That is, one is precision and accuracy. That is the experimental measurement. That is the uncertainty associated with it. That means the resultant precise and accuracy. The precision and accuracy. First, the precision is closing the variance of measurement for the same quantity, while accuracy is the agreement of a particular value, that is the true value of the result. For example, if I give student A, student B, and the student C, that is the resultant for the value. For example, they have done some volumetric analysis, whatever it is. Just imagine the resultant, the accurate value is, that is the accurate value result is, we know that is 2.00. For average gram, that is 2.0. Student A reports the first experimental one is 1.95, and the student this is experiment 1 and this is experiment number 2. That experiment value is 1.93 gram. Similarly, student B reporting 1.94 and 2.05 gram, and the student C 2.01 and 1.99. Look at here, the student A reports that is 1.95 and the 1.93. So the values are precise. So these values are precise as they are close to each other but not accurate. So yeah, the accurate value is what? 2. So this is not accurate. These two values are close to each other, 1.95 and 1.93. See another here, the next student B, 1.94, 2.05. There is no precision and there is no accuracy. That values are too different. So they are not close to each other. Okay, and then look at the student C. The student C, yes, 2.01 and 1.99. These values both precise and accuracy is there. How it becomes mean you have to take average. So average means 1.95 and 1.93, it will become 1.94 gram. So all are grams. Okay. Take this 2.05 and 1.94, this you have to take average. Average means 1.995 gram. This, look at this, 2.01 and 1.99, this average will become 2.00 gram. So this is the accuracy. Okay, the student C, that is the uncertainty in the experimental or the calculated values indicated, that is monitoring, that is the mentioning the number of the significant figures. So this is called significant figures. This is we can write for example in the last two, if you write the resultant, that is 11.2 ml, we say that is 11 is a certain, that is 2 is a uncertain. This is 11 is a certain value and this is the uncertain. Okay, the uncertainty would be plus or minus 1 in the last digit. So unless otherwise stated, the uncertainty is plus or minus 1, plus or minus 1, the last digit always understood. So there are some rules. The significant figure, figures having some rules. First I will tell you that rule 1, that is, first rule is all non-zero digits are significant. For example, in 285 centimeter, so here 3 significant figure, and because of you have to count the number, 3 significant figure and 0.25 milliliter, there are 2 significant figures. Here the 2 significant figures, here 3 significant figures. Then the rule number 2, zeros preceding the first non-zero digit are not significant. So such zeros indicate the position of the decimal point. For example, 0.03, this has one significant figure, and 0.0025, this is two significant figures. You do not count these 0 because the 0 preceding first non-zero digits are not significant. This is not a significant. Okay, zeros between two non-zero digits. So for here, zeros between, this is the 2, and third rule is zeros significant. Zeros between two non-zero digits are significant. For example, 2.004. So this will become in between the 0. So you have to count. This is a significant 1, 2, 3, 4. This is 4 significant figures. Then the fourth one is the zeros at the end are right of a number, the significant provided they are on the right hand side the decimal point. For example, 0.200. So this is 3 significant figures. You have to count this 0 also. So this is a significant. Okay, this is 3 significant. But if otherwise the terminal zeros are not significant, if there is no decimal point. So if there is no decimal point, for example 100 only, that is one significant figure. But 100 point has 3 significant. 100.0, this is 4 significant. there is no point means just one significant. If there is a point means this is a 3 significant. Point after 0 also you have to take the count. So such numbers are better represented in the scientific notation. So we can express the numbers like 100 is 1 into 10 power 2. The 100 you can write 1 into 10 power 2 for one significant figure. For this 3 significant figure you can write 1.0 1.0 into 10 power 2. Okay, this is for one significant figure, this is for 3 significant figure, and sorry 2 significant figures, and 1.00 10 power 2, this is for 3 significant figure. This is 2, this is 3, and this is 1. Okay, then the last one is the counting the numbers. The counting the numbers of object. For example, 2 balls are 20x. 2 balls are 20x that have infinite significant figures, as these are the exact number and can be represented by the writing the infinite number, that is a 0 after placing the decimal, so that 2 is equal to 2.0000 like this. So 2.00000 like this bar, or you can write 20x 20.0 after 6 zeros. Okay, so this in numbers and written significant notation that all digits are significant. So example, 4.01 into 10 power 2. So you have to count 3. So this is a 3 significant figure, and 8.234 into 10 power minus 3. This will become 4 significant figures. Addition and subtraction of significant figure. Here the result, that is, cannot have more digits to write the decimal point of the either original number. For example, here 12.11 and 19.0, then 1.012. Now the value is what? 32.112. Here look at this 19.0. This 19.0 is only one digit after the decimal. See, look at here, only one digit, here 2 digit, here 3 digit. So after one digit, the one after the decimal point, the result should be reported like this. See, the result value is what? 32.112. Just you have to stop 32.1, because this is one the least number is 19.0, but here 2 then 3 after the decimal point. You have to stop. If the present like this, mean you have to stop after decimal 1 point is enough. Okay, so this is addition and subtraction significant figure. Then multiplication and division. Multiplication and division significant figures. Here this is the result must be reported here. In these operations you have to report the no more significant figures are as are there in the measurement. Few significant figures like this, 2.5 into 1.25, just you have to write 3.125. Since 2.5 has, see, this 2.5 has 2 significant figures, and the result should not have more than 2 significant figures. So that resultant value is what? 3.1, because here 2 significant, this is 3 significant, the least one is what? 2 significant. So that the result value you have to write 3.1, not 3.125. just you have to stop 3.1. This is what the limiting of the result required number of the significant figures was done in the above mathematical operations only. Okay, so the round of value, see, you have to keep that round off value in mind. For example, rightmost digit to be removed in the more than 5. The preceding number increased by 1. For example, it is 1.386. The last digit was 6. More than 5, you have to the round off value. So next 338, 3.38, it will become 0.39. So you have to remove that 6 and you can write 1.39. Already I told that is plus or minus 1. So positive more than 5 means you have to write plus 1. Below 5 means you have minus 1. Okay, just simple like this one. The rightmost digit to be removed in the less than 5, the preceding numbers not changed. That means you cannot change, not minus 1, you cannot change that value. For example, 4.334. So you have to write the original value only. That's a 4. You can remove that 4 and just you have to write 4.33. More than 5 only you have to add the round off value, and less than 5 means this is the round off value. The rightmost that is to be removed in the 5, then the preceding number is not changed. But even the number of buttons increased by 1 and is an odd number. That for example 6.35. That's be rounded by the removing of 5. We have increased to 3 to 4, giving 6.4. Okay, we have to remove this. Just giving of that below 5 you have to follow, above 5 you have to follow like this, and 5 means you have to follow like this. Just the round off value is 6.4 the result. However, 6.25, the rounded value is what? 6.2. Okay, just this is enough. Okay, student. Then the dimension analysis. The dimension analysis, the third one. So the dimension analysis, calculating this, there is a need to convert unit from one system to other. So the method that is the factor, this is called the unit factor method or dimension analysis method or factor label method. So I will write one example. Example, piece of metal is 3 inch. That is what is the length of length in centimeter? What is in inch? What is the length in centimeter? So here we know that the 1 inch is equal to 2.54 centimeter. So the equivalence value we can write, that is 1 inch divided by 2.54 centimeter, that's equal to 1. So here this equal to 2.54 centimeter divided by 1 inch. So this equals to what? 1 inch divided by 2.54 centimeter equals to what? 1. And 2.54 centimeter 1 inch divided by 1 inch also equals to 1. Okay, this equals to 1 and this equals to 1. So both these are called unit factor. That if a number is multiplied by this unit factor, that's mean unit factor is 1. So say that the given example, like suppose in 3 inch converts to centimeter, means that's 3 inch. That means 3 inch equal to what? That is 3 inch into 2.54 centimeter divided by 1 inch. So that it will become what? 3. So inch cancel, inch and inch cancel. So 3 divided by 3 into 2.54. 3 into 2.54 centimeter. So the resultant value is 7.62 centimeter. So the now the unit factor by multiplied by multiplication of the that unit factor, like this 2.54 centimeter by 1 inch. So this is the case. Okay. It should be noted that the above example, that unit can be handled just like that. Okay. The other numerical part. So this may be this, the inches cancelled, usually they cancel, and divided, multiplied, whatever it is. Okay. So this is called dimension analysis. We can discuss the law of chemical combination in next class.